In this video, we're going to look at working with velocity and net change. So we should hopefully remember from our derivative work that if we have a position function s of t, to find the velocity and the acceleration, we take the derivative. So s prime of t, lost my page. So we know that s prime of t would equal the velocity. And if I take the second derivative of the displacement, which would be the first derivative of velocity, I would get acceleration. So that means if we know velocity or acceleration, we can work backwards to find the position function using integration. So if I integrate a velocity function, I will get my displacement function. If I integrate my acceleration function, I will get my velocity function. Now, just like when we were integrating and we talked about finding the net area versus the total area, the net displacement, once I take my integral of velocity, is given over the integral from a to b of the velocity of t dt, but to find the total displacement, I have to take the absolute value. So here we're given that the velocity of a function with respect to time is negative t squared plus 4t from 0 to 5, and we want to find the displacement. Now, since it doesn't say total, it implies that we're doing the net. So we have to do the integral from 0 to 5 of negative t squared plus 4t dt. So taking my integral, I'm going to have negative 1/3 t to the third plus 2t squared, and I'm evaluating that from 0 to 5. So 5 cubed is 125, so I'm going to have negative 125 over 3. T squared, when t is 5, is 25. 25 times 2 is 50, so I have plus 50. And from that, I am subtracting 0. Negative 1/3 t to the third is 0, plus 2 times 0 is 0. So negative 125 over 3 plus 50, I need common denominators. So that would be 150 over 3. So my net displacement is 25 over 3. Okay, so now same problem, but we want to find the total distance traveled, right? The actual travel distance is not the same thing. If you think about it, I could start here and I could go for a run, and I could run all the way over here, and I ended up back where I started. My displacement is 0 because I started and ended at the same spot. My net displacement is 0, but I want to know how far I actually ran. So in order to do this, we need to take a look at our graph so we know where is it positive and where is it negative. So if I graph this, I know my zeros are 0 and 4. And I'm looking for when it goes to 5, so when I plug in 5, I find that my graph is going to be at negative 5. And you can make a table of values, and I'm just doing a rough sketch here. I did not actually calculate what my height is, but I have this area here, and then I also have this area below the curve right here. So to get my net, I need to look at this positive area, and I need to figure out what this area is and make it positive. So I'm going to break this to two integrals. So I'm going to integrate from 0 to 4, negative t squared plus 4t dt. And then because I know that red area is negative, I'm just going to say I'm going to subtract what that area is from 4 to 5 of negative t squared plus 4t dt. So we know that this breaks down to negative 1/3 t cubed plus 2t squared, and I'm evaluating from 0 to 4, minus negative 1/3 t cubed plus 2t squared, but I'm evaluating from 4 to 5. So plugging in, I'm going to have negative 64 over 3 plus 4 squared is 16, 16 times 2 is 32. And then from that I'm subtracting, I'm plugging in my 5, so I have negative 125 over 3 plus 50 minus negative 64 over 3 plus 32. So when I clean these up, I got common denominators. The 32 becomes 96 over 3, negative 64 plus 96. this is going to be 32 over 3 minus negative 125 over 3 plus this would become 150 over 3 will give me 25 over 3 minus, and here we know negative 64 over 3 plus 32, we just did that. That's going to be 32 over 3. So now I have 32 over 3 minus 25 minus 32 is negative 7 over 3. So I have 39 over 3, which gives me a final net displacement of 13. So remember, we have to take our looks at our graph so we know where the area is positive and where it is negative so we can break up those integrals. Now here we're given that the acceleration with respect to time is negative 32. They told us our initial velocity is 50 and our initial displacement is 0. We want to find our position and velocity functions. So to find my velocity, I have to integrate my acceleration. Okay, so I'm integrating the integral of negative 32 dt. So I would get negative 32t plus some constant because I don't have bounds. However, I know that my initial velocity, v of 0, is equal to negative 32 times 0 plus c, and that equals 50. So this tells me that c has to equal 50. So my velocity function v of t is given by negative 32t plus 50. And now to find my displacement, I need to integrate my velocity. So s of t is equal to the integral of v of t dt. So I'm doing the integral of negative 32t plus 50 dt. So this is going to become a t squared, so it's negative 16t squared plus 50t plus a constant. And again, it told me my initial position is 0, so to solve for c, I have 0 equals negative 16 times 0 plus 50 times 0 plus c, so my c value is 0, so I can say that my position function s of t is negative 16t squared plus 50t.